Thank you very much for the introduction, and first of all, thank you for inviting us to present the C-Cells project here. And sort of from what we've just heard, we're more or less now going one level up in system complexity, I would say, and rather trying to look top down what the C-Cells project is about. Let's see when it shifts. Saying it's supposed to do so. Now it does. The C-Cells project itself is part of a rather large call from the Federal Ministry of Economics in Germany, and the aim of this so-called SynTech call was to demonstrate large-scale solutions of a future energy system. So this was the official call, and as you can see, there's been quite some preparation time that's been going on. And it turned out that the ministry now wants to fund 5 large consortia looking at these issues. And as you can also see, 3 of them, so the northern ones, so ENERGIE, New 4.0, and WindNode, are focusing around getting more wind energy into the German grid, and they're trying to solve especially problems related to this issue. The C-Cells project itself, which is, as we all hope, supposed to start in January next year, so we're just at the brink of getting operational, is the only consortium that's focused around PV and how to integrate large amounts of PV and also how to balance load and generation, especially in the southern German region. So there's a couple of main points that we wanted to address with C-Cells, and this is also reflected in the name C-Cells already, because first of all, what it's meant to do is to serve as a large showcase in the, as we call it, solar arc. So it's basically Bavaria, Baden-Württemberg, and Hesse. And as we've been mentioning, we try to especially look at regions with high PV penetration, but also in regions around the Munich area, Stuttgart area, where we have a large concentration of loads that have to be supplied efficiently. And the core of it is, so to say, this cellular approach that also came out of a VWE study. And the idea is that we connect diverse cellularly organized energy infrastructures in a way that these cells, first of all, work autonomously. So they try to balance load and generation locally first, and then if this is not sufficient, they try to get their balance on a larger scale. I'll show you in a second how this translates into a real idea, and how we also try to use that cellular concept in different ways throughout the project. It's not only about physics and engineering, but it's also, if you want to go into large-scale demonstration, mostly about selling in a large sense. And selling means also providing business models and providing products in the end that grid operators, suppliers, manufacturers, etc., can study and can in this sense use to get the concepts actually running. So it's not, as I said, not only about technology, it's also to a large degree about how to make this mass compatible in terms of business models. And the third key element, I would say, is also that we more or less all know that it's not just about energy flows, it's also about kind of getting the right information from all sorts of sensors, systems, and technologies together to, for example, we just heard the solar prediction and the importance of predictions, and it's not only this, but also grid data. What C-Cells tries to do is to establish an IT platform. We call it the IIS, the Infrastructure Information System, which is supposed to exactly do that and bring different data from different suppliers together so that they can actually be used in order to balance load and generation more efficiently. This cellular concept is in principle rather simple. As I said, the idea is to define cells that are first of all trying to solve their energy issues, as I would say, autonomously. And if this is not working, basically they're trying to exchange energy and information with neighboring cells to get their balance done. And in order to do so, there have to be appropriate products so that this flexibility and energy can be traded, in a sense that in the end, the system as an entity is still balanced. The concept of a cell itself is not something that is strictly defined, in a sense that, for example, a cell is just a neighborhood or just a household or just a grid area. A cell can be basically anything as small as a building up to basically entire grids or transmission grids. It can even go as far as defining basically virtual cells as an analogy to the virtual power plant concept. So depending on the problem basically, or depending on the specific question you ask, you define the cell as an entity. So it's not a rigid, strict concept. It's something that's really flexible and adjusted to the problem that we want to solve. You'll see a couple of examples in a minute. So then I hope this becomes entirely clear. The region itself, so it's basically the entire south of Germany, we think is a very good showcase for doing such a large-scale project. Not only what I've been mentioning, that we have a very interesting balance between rural regions with quite high PV penetration that are already above 100% of the local load and load centers, but also we have already about 0.8 million prosumers in the region, so there is already a large community of renewable energy producers that we can draw on. And also another issue that will seriously affect the energy landscape in this region is the phase out of nuclear energy. So there are challenges, quite a few actually, but there's also a solid base of prosumers and a lot of infrastructure that you can already build on in order to realize the energy system of the future, as Syntec calls it. The idea, as you can see here, is actually to, first of all, or primarily increase the integration of PV. Here, this is a map that's just supposed to show you the share of renewable electricity consumption depending on the production. So the more blue it gets, basically the more the share can be covered. And dark blue even means that over a year you even produce more than you can consume. And this is already now, especially in these regions here in Bavaria, becoming an issue for grid operators, that simply throughout the day it's an issue to basically get the PV electricity into the local distribution grids. And so it's not just a problem that will occur in the future, it's in some regions already a problem. What C-Cells tries to do is to define, as I've been saying, all kinds of different local cells where different aspects will be tested, and especially the interplay between these different aspects will be tested. So, for example, we have a large distribution grid area here in Schwäbisch Hall. Then we have smaller issues here. There's Stuttgart Airport, basically as a local cell. There's also, we're working together with ISC also on this one, where they will also be in charge of another cell, which is the so-called E4 area. So there's all sorts of varieties, as you can already see, even on this level, and there's also all sorts of varieties on a grid level, so to say. Especially the smart meter rollout that will also start in 2017 is an issue where basically now, especially grid operators, want to find out how business models for smart meters can be established, and one large advantage of these Syntec projects, and C-Cells, as I said, is one of them, is that there will be special rules and regulations for these projects, so that actually companies can try new business models without running into problems that basically they are not profitable under the current regime. And so there are opportunities which, to my knowledge, are unique in Germany to try new business models and also to try to get into new revenue streams, especially for those companies now trying to establish new models. As I said, it even goes up to the two large TSOs that we have in the consortium, so TransnetBW and TenneT, even with connections in the south to the Austrian power grid. So it's not even, the project is not meant to be like a monolithic block that's defined. It's rather meant to be an open system that extends and that also tries to integrate new bits and pieces as we go along these 4 years of project duration. As you mostly all know, I think, and also the reason why we're here now is that there have been a lot of very interesting and also very innovative projects in this entire field that have been going on in the last couple of years and are still going on. So in C-cells, it's to some degree not about like getting extremely new ideas to be developed on their own. That this is one part of it, but it's not the key part. The key part is what you can see here is to make these different, or to try out different approaches and also to try to see how they integrate and how they work with each other rather than working in an isolated manner. So the concept, as we see, is an idea that the cells can even, in principle, extend to the other projects, and we also see a lot of synergies to the other 4 projects because, of course, it's a competition of ideas, so to say, but it's still, the idea is to develop a system that's compatible all over Germany and ideally all over Europe. And there's also been one project, Kalia, where actually there's a meeting tomorrow also with ISC where we're actually trying to do this. We're trying to see whether parts of this C-cells ideas also work all over Europe. So this extends all the way from Belgium down to Turkey. So it's not a concept that's meant to be like an isolated idea. That's what I wanted to say here. And if you look at the consortium that's driving C-cells, it's also something that's, I would say, rather specific to such a large project, because it's not the case in this project that we have one large partner, one large company that's more or less driving this partner or this project. In total, it's around 50 partners, and we're trying to also organize the project in a kind of decentralized cellular way. So as we all know, obviously there is no blueprint already to the energy system. So we don't have a master plan to be executed. We think that we have some good ideas, and now the question is which ideas actually work on a large scale. But still, the belief here is that nobody has the single solution. So we need to work together in a rather decentralized fashion where we can have an open competition also between rivaling concepts within the consortium. Just a few words about how it will be actually organized. So also we try to group it into 7 partial projects, as the project itself is even too large to be organized, and especially those here are the key ones. So one will just focus on business models and everything that's environmental, from regulation to standardization and so on. Then part 3 is mostly on IT and how to set up this infrastructure information system. Project 4 and 5 are mostly centered around grids, and 5 especially around how to integrate basically grids and markets, how to establish trades, services, agents, and so on. And the parts where actually the demonstration takes place are the parts 6 and 7, where these differently shaped cells that I've just been mentioning will actually be realized. the very exciting bit is that, especially in 6 and 7, we'll have a huge diversity of different projects where it's still open also to us as a project coordinators, what will actually turn out to work nicely and what will probably be a solution that's not going to work within these large frameworks. So it's a really exciting situation also for us to come. You might also ask, how will this idea look technically? So what we are trying to do is, I'll just show one example actually, is to again also have both the physics, so to say, and the market within the system. So this is probably just a very rough sketch of today's system. So we have still on the high voltage level, we have the classical generation bits, and then here we have already a significant share of PV and wind, and consumers mostly connected to the low voltage range. Now, what's going to happen is we'll have still an ever-increasing share of PV and wind, more and more prosumers coming in, not only consuming but also selling, CHP systems and everything, or most of it is going to happen at the lower voltage levels. With this redesign of the energy landscape as we know of today, also new roles will come in, and especially when you look at the market level here, there is a couple of services that will become more and more important, especially when it comes to short-term flexibilities and how you market them in order to balance or to do a real-time balance between these many small generation units, a lot of small consumers, and how to basically get these products also accessible to a larger range. So there's a lot of areas. So here, this is what we termed grid flexibility, which will definitely evolve then, especially this field of virtual power plants, real-time applications, real-time production, smart meter administration. This will be a large construction side that we'd like to address within the project, but also in the region here where there's generation and loads, how we can in the midterm also integrate more sectors, so also electromobility and heating, heat pumps, etc., into the system without basically compromising safety and security as we know of it today. A lot of construction sites, especially in this range, and C-cells will try to solve some of them throughout the next couple of years, and we're confident that we can solve some of them, we hope, but at least we will have, after the project is done, we'll have some ideas how to solve most of them, and in the end we'll have a clear idea of what's going to work and what's not. Also, such a large project wouldn't work without support from the governmental side, so all the ministers of the environment of all the states supported the project, and we hope that this will continue throughout the next 4 years and to actually get things done and to make it a success. So just very briefly to sum up what the idea of C-cells is first of all, we'd like to follow this cellular approach without kind of a clear top-down structure rather than a decentralized structure where the cells work autonomously and then they balance load and generation locally before they reach the next grid level. The C-cells also tries not to kind of have the solutions already, but rather have the communities and also the companies involved in an active participation approach. Throughout the project, there's a large campaign also trying to foster that. We think that southern Germany is a particularly good example of trying because of its landscape in terms of loads and generation, because of its rather large share of PV already, and basically also for that reason that we didn't want to have one large EVU on the top. There's been the so-called smart grids BW. It's a project management company basically that was funded by the Smart Grids Initiative to realize the project and to run it. And yeah, we hope that you'll have the chance to hear about some of the C-Cells outcomes and results in the near future. And with this, I'm happy to take questions, and thank you for your attention.